So another counting principle that we can use when selecting objects from a larger group of objects is called combinations. And a combination is kind of the same idea as a permutation, except we don't care about the order in which the objects are selected. So if I'm looking for, 3 students to present and the class size is 8, there's a difference between the order in which they present and I just want these 3 students to present. So here's where we're at. So theorem, number of R combinations of a set of n distinct objects is called CNR. So remember, permutations was P with an N and R. And basically think about it this way. If you have R objects, there are R factorial ways to put them in order, but we know that, we don't want them in order, so that we divide out the number of ways to put them in order. So this is a convenient way to think about it, but this is the formula, and quite honestly, I find a lot more use out of that because notice that the numbers in the denominator, the R and the n minus R, add up to n. So it makes it really easy to remember how to compute it. Okay, so let's take a moment to look at when we would use such a thing. So in number 1 here, and how many committees of 3 people can be formed by selecting from a group of 8 people? So there, we don't care about what order they're selected in. So if John, Tom, and Harry are in the group, that just means they're in the group. The order they were selected has no bearing on being a different group. So this means that we have C, 8, 3, and that means that we have 8 factorial over 3 factorial, 5 factorial. And that's going to be, well, let's see, 8 factorial is, well, I'm going to write it this way. So I'm going to do 8 times 7 times 6 times 5, 4, 3, 2, 1 is 5 factorial. And notice why I stopped at 5 factorial, because I want to cancel out the bigger one. So those go away. 3 factorial is equal to 6, so those go away. We only have 56 different possible groups of 3. Okay. How many 5-card poker hands are possible from a deck of 52 cards? Again, if I have the ace, king, queen, jack, and 10 of the same suits, say hearts or diamonds or clubs, first I'm going to do is go all in so I win the big money. But the second thing is I don't care what order I got them in because I can put them in order myself. So this is another one of those situations where we're going to use the combination. We're selecting 5 cards from a group of 52. So it's going to be 52 factorial over 5 factorial, 47 factorial. And I don't have that memorized. So I'm going to pull out the calculator here. And let's just see what we get. So on this calculator, I can go to Math and PRB, and I have an NCR button. Now, the way it works on my calculator is, oh, well, I put it up there. I have to put a number before the C and after the C. So the number before the C is the larger one, the 52. The number after is the 5. And that is how many different poker hands are possible. So just about 2.6 million. 2598960. So there we have that. And then one that kind of extends the concepts a little bit. A farmer wants to buy 3 cows, 2 pigs, and 4 hens from a man who has 6 cows, 5 pigs, and 8 hens. So in this situation, we're really doing this task in 3 steps. The first thing we're going to do is buy the cows. The next thing we're going to do is buy the pigs. And I'm not going to try to draw these. I'll save you the agony. And then the last step, we're going to try to buy the hens. And again, we don't care what order we bought them in. The order, the group is the group. So 6 cows, we want 3 of them. So this is going to be 6, choose 3. For the pigs, we have 5 to choose from, and we want 2. So if we get Betsy and Petunia, it doesn't matter what order we got them in. So we're just selecting 2 out of the group of 5. And then we have 8 hens to choose from, C4. And let's multiply that out using the calculator just to get a little bit used to the notation there. So I'm just going to bring back the last thing I typed because it was a combination. I don't want to have to fight through the menu to get that. 6, whoops, Ah. Let's do second answer again. Okay, so going to go to math PRB 6C3 times, now I'm going to go to math again, math PRB NCR 5C, oh, for some reason that didn't go where I wanted it to go. There we go. Okay, math PRB NCR. I'm not sure why this isn't doing what I want. Okay, so let's just do it this way. So math NCR 6C3 is 20. 5C2 I can just tell you is 10 because it's 5 times 4 over 2. Now 8C4, so that's going to be 8 times 7 times 6 times 5 times 4 times 3 times 2. Okay, let's do it this way. Math, PRB, okay. 8C4 is equal to 70. So this means that there are, well, 2 times 1 times 7 is 14, and 3 zeros means 14,000 different groups of animals. And remember, if one animal is different, it's considered another group. But if we're just using the same animals and picking a different order, we don't care about that. That's not considered a different group for us. Okay, so when you come back, we'll look at some mixed examples deciding between combinations and permutations. So be sure to stay tuned for that. Thanks so much.